Welcome to Study Loop.
In this problem, we are going to be focusing on quantifiers, where we're given a statement and we have to find essentially the domain of that statement using our knowledge of mathematical quantifiers. Now, quantifiers are very important and they're going to come up and be significant when you get into introductory proofs and proofs later on. But for right now, we're just getting used to the concept of quantifiers and how to use them and the difference between them. So please, while you're going through this video, please look back at the problem to remind yourselves of the original statements that we were given. I think that's going to help if you're new to quantifiers and learning it for the first time. Okay, so for part A, we're going to let the propositional function be y of x. And we're going to say x is the school. Then we're going to say we have this additional function u of x is that x has visited Uzbekistan. So the domain of this, using these conditions, is that there exists y of x and u of x. So what does that mean? There exists someone in the school who has visited Uzbekistan. Now suppose that a person x has visited a country y, which will denote v of x comma y. So now when we take all of this into account, we can say that the domain of the original statement is that there exists y of x and a v of x comma Uzbekistan. Now let's move on to part B. We're going to follow essentially the same procedure. Let's consider functions c of x and p of x. So the domain of just these functions at the moment would be for all x, we have y of x maps to c of x and p of x. So suppose that there is a person x who studied subject y, and we'll denote this by s of x comma y. So the domain of this, remember we're considering the grade and calculus, is that for all x, this would hold. Y of x maps to s of x comma calculus and s comma x c plus plus. Now on to part C. We're going to follow the same procedure. So we're going to let b of x and m of x be functions. B denotes bicycle, m denotes motorcycle. So the domain of this would be that for all x, we have this thing to be true. Y of x maps to the negation of b of x and m of x. Now remember, negation means it's essentially not. So this is not b of x and m of x. Now suppose that person x has an item y, given that we have in this essentially notation, we have O of x comma y. So now we have to find the domain of our original statement. For all x, this would be true. Y of x maps to the negation of O of x comma bicycle and O x comma motorcycle. Now let's move on to D. We're going to let h of x be that x is happy. The domain of this would be that there exists an x such that y of x and not h of x. So this is saying that there exists a person such that they are not happy. So suppose a person x is in the mental state E of x comma y. So the domain of this, taking all of these conditions into account, is that there exists an x such that y of x and not E of x comma happy. And now finally, we are going to say let t of x for part E, for t of x be such that x is born in the 20th century. So the domain for this statement alone would be that for all x, we have y of x maps to t of x, so that for all people, they would be born in the 20th century. So suppose a person X is born in Yth century, maybe not the 20th century. We'll denote that by B of X comma Y. So the domain of this original statement would be for all X, such that Y of X maps to B of X comma 20. So I hope that this problem helped you understand or maybe even introduced you to the notion of quantifiers and how we can use them. Particularly, we have to define all of the conditions we're going to be quantifying, and then we could use things such as for all, for every, such that to essentially take a statement in English terms and move it into a mathematical statement.